Hello and welcome to this video from Heybridge Maths Department. This week we're going to be having a look at some of these really nasty ratio problems that they like to put on GCSE higher tier papers. Question 1. The ratio 10 to A is equivalent to 8 to A plus 10. Find the value of A. So what they're saying is that 10 to A is equal to 8 to A plus 10. So what we can say is that 10 over A is equal to 8 over A plus 10. So I'm going to take my A over here and multiply, and I'm going to take my A plus 10 over here and multiply. So I'm going to get 10 A plus 10 equals 8A. So I need to expand this bracket. So remember, brackets means boxes. So I'm going to get 10 times A is 10A, and 10 times 10 is 100. So I'm going to get 10A plus 100 equals 8A. Now I'm going to take my 8A over to the left and subtract it. So that's going to leave me with 2A plus 100 equals 0. And then I'm going to take my 100 over to the right, and it will become negative. So I will have 2A equals negative 100. And then I'm going to take my 2 across to the right and divide by 2. So that will give me A equals minus 50. And I can check that my answers are correct. Well, my answer is correct by substituting back into my two ratios. So my first ratio would be 10 to, well, when A equals minus 50, it will be 10 to minus 50. And if I divide that by 10, my simplified ratio will be 1 to minus 5. And on the other side, I'm going to have 8 to minus 50 plus 10. And that will give me 8 to minus 40. And if I divide by 8, I'll get 1 to minus 5. So by checking, I can see that my two ratios are equivalent. So that value of A equals minus 50 means that 10 to A is equal to 8 to A plus 10. So I know that my answer is correct. Question 2. I am choosing shapes out of a bag. The ratio of blue shapes to red shapes is 2 to 1. For the blue shapes, the ratio of spheres to cubes is 2 to 3. For the red shapes, the ratio of spheres to cubes is 1 to 4. Given that there are 12 red spheres, how many blue cubes are there? Right, so I know how many red spheres there are. So I'm going to start with this ratio of red spheres to red cubes, and I'm going to work backwards. So red spheres to red cubes is 1 to 4. And I have 12 red spheres. I'm going to have 4 times as many red cubes. So I'm going to have 48 red cubes. So altogether, I'm going to have 60 red shapes. Right. Now, the ratio of blue shapes to red shapes is 2 to 1. I've worked out here that I have 60 red shapes, so I must have twice as many blue shapes. So I'm going to have 120 blue shapes. My ratio of spheres to cubes for blue, so blue spheres to blue cubes, is 2 to 3. So altogether, that ratio has 5 parts. Those 5 parts make up 120 blue shapes. So one part is going to make up 120 divided by 5, which will be 24 blue shapes. My blue cubes are 3 parts of my ratio, so my blue cubes will be 3 times my 1 part of the ratio, which is 24. So altogether there will be 72 blue cubes. Question 3. I am on a farm with pigs and horses. The ratio of pigs to horses is 4 to 1. The ratio of adult pigs to piglets is 1 to 5. And the ratio of adult horses to foals is 3 to 1. What fraction of the animals on the farm are babies, that is foals and piglets? So I'm going to start off pigs to horses. And pigs to horses is 4 to 1. So the ratio has 5 parts altogether. So 4/5 of the animals on the farm are pigs, and 1/5 of the animals on the farm are horses. Now, if I look at pigs to begin with, adults to babies. So my ratio of adult pigs to piglets, so adults to babies, is 1 to 5. And I've got 6 parts in that ratio altogether. So 1/6 of my pigs are adults and 5/6 of them are babies. So my number of piglets is going to be 5/6 of 4/5. And remember that when we're dealing with fractions, of means multiply. So that's going to be 5/6 times 4/5. So that's going to give me 20/30, which is 2/3. So 2/3 of all the animals on the farm are piglets. Now let's deal with horses. So my ratio of adult horses to foals, so adults to babies, is 3 to 1. And I've got 4 parts to this ratio. So 3/4 of my horses are adults and 1/4 of my horses are babies. So my number of baby horses, my number of foals will be 1/4 of, so 1/5 of all the animals on my farm are horses. So 1/4 of 1/5, which is 1/4 times 1/5, which is 1/20. So I now need to add these together. So 2/3 of my animals are piglets, and 1/20 of the animals on my farm are foals. The lowest common multiple of 3 and 20 is 60. So if I turn those into equivalent fractions, I'm going to get 40/60ths are piglets and 3/60ths are foals. So altogether, 43/60ths of the animals on the farm are babies. Question 4. The ages of Adam, Ben and Caleb are in the ratio 5:7:11. Next year they will be in the ratio 8:11:17. How old are they all now? So I've got Adam, I have Ben, and I have Caleb. And at the moment the ratio of their ages is 5:7:11. Now I don't have any age for them. I don't know what one share is worth. So I'm going to call one share of the ratio X. So I'm going to say that at the moment Adam is 5x years old, Ben is 7x years old, and Caleb is 11x years old. And then I'm going to look what's going to happen next year. So next year, Adam will be 5x plus 1 years old. Ben will be 7x plus 1 years old. And Caleb will be 11x plus 1 years old. And the question tells me that that will be the same as their ages being in the ratio 8:11:17. Now I only actually need to use 2 people to be able to work this out. So I'm just going to use Adam and Ben. Because Adam and Ben's ages are in the ratio 5x plus 1 to 7x plus 1 and 8:11. So I can just use 2. I don't need to use all 3. So 5x plus 1 to 7x plus 1 is the same as 8:11. So that means that 5x plus 1 over 7x plus 1 must be the same as 8/11. So I'm going to take the 11 over here. So I'm going to move the 11 across to the left and multiply. And then I'm going to take the 7x plus 1 over to the right and multiply. Then I'm going to expand the brackets. So remember that brackets means boxes. So let's have an 11 there and a 5x plus 1 there. So I'm going to get 55x plus 11. And then let's also expand the right hand side. So I'm going to get 56x plus 8. So I'm going to take my 55x across to the right and subtract it. So I'm going to get 11 equals x plus 8. Then I'm going to take my 8 across to the left hand side and subtract it. So I'll get x equals 3. So how old are they now? So that's my original ratio. So Adam is going to be 5 times x, so he's going to be 5 times 3 years old, which is 15. Ben is going to be 7 times 3 years old, which is 21. And Caleb is going to be 11 times 3 years old, which is 33. I can check that my answers are correct by substituting into this second ratio. So 5x plus 1 would be 16. Seven x plus 1 would be 22. And 11x plus 1 would be 34. The highest common factor of 16, 22 and 34 is 2. And that will reduce to 8, to 11, to 17, which is the correct ratio. So you know that these are your correct answers here. So now Adam is 15 years old, Ben is 21 years old, and Caleb is 33 years old. Question 5. A business has 2 different offices, one in London and the other in New York. The ratio of the number of staff in the London office to the New York office is 3 to 5. Employees of the business are either part-time or full-time. In London, 30% of the staff are part-time. In New York, 20% of the staff are part-time. Given that the business has 38 part-time members of staff, work out the total number of employees. So let's start off with this London to New York ratio. So the ratio of staff in the London office to staff in the New York office is 3 to 5. So we've got 8 parts in the ratio altogether. So that means that 3/8 of the staff are in the London office and 5/8 of the staff are in the New York office. Now in London, 30% of the staff are part-time. And if I change that into a fraction, that will be 3/10. So altogether, part-time staff in London will be 3/10 times 3/8 of the number of staff in the company, which will be 9/80. And then let's have a look at New York. So that's 20% of staff are part-time, and that's 1/5. So 1/5 of 5/8, and remember of means multiply, will be 1/5 times 5/8. So that's going to be 5/40. And if I change that so that it also has a denominator of 80, that's going to give me 10/80. So the total fraction of staff that are part-time is going to be 9/80, add 10/80, which is 19/80. That 19/80 represents my 38 members of staff. So in order to find out how many staff I have altogether, I need to do 32 divided by 19/80. So I'm going to keep change flip. So I'm going to keep 38, change the divide to a times, and flip the second fraction upside down. And I can divide 38 by 19, so that's going to give me 2, and that's going to give me 1. So I'm just left with 2 times 80, which is 160. So altogether there are 160 staff in the company. Question 6. Liquid A and liquid B are mixed together in the ratio 2 to 13 by volume to make liquid C. Liquid A has density 1.21 grams per centimetre cubed. Liquid B has density 1.02 grams per centimetre cubed. A cylindrical container is filled completely with liquid C. The cylinder has radius 3 centimetres and height 25 centimetres. Work out the mass of the liquid in the container. Give your answer correct to 3 significant figures. You must show all your working. So I'm going to begin by working out the volume of the cylinder. So the volume of a cylinder is the circular cross-section pi r squared multiplied by the height h. So that's going to give me pi multiplied by my radius is 3, so 3 squared, multiplied by my height, which is 25 centimetres. Do just check in these questions because they may give you a height in one unit and the radius in a different unit, or they might give you the diameter instead of the radius. So make sure that you've got the correct values and that they're both in the same unit, so both in centimetres, both in millimetres, before you substitute them into your formula for the volume or area of anything. So 3 squared is 9, 9 times 25 is 225, so the volume of my cylinder is 225 pi centimetres cubed. And you'll see why I've left it in exact terms with pi in a moment. So I've got my 2 liquids A to B. And they're in the ratio 2 to 13. So altogether, that means that I've got 15 parts in my ratio. So one part of my ratio is going to be the volume of my cylinder divided by the number of parts in the ratio, and that's going to give me 15 pi. That's why I left it as pi centimetres cubed, because then it's a lot simpler. You haven't got to write out strings of decimals until later on in the question. So the amount of liquid A I want is going to be 2 parts of the ratio. So that's going to give me 2 times 15 pi, which is 30 pi. And the amount of liquid B I want is 13 parts of the ratio. And 13 times 15 pi will give me 195 pi centimetres cubed. And I can check that I've split that ratio up correctly, because 195 pi plus 30 pi is 225 pi. Now, if you think back to physics, we have density equals mass divided by volume. I want to work out the mass of the liquid in the container. So density times volume is mass equals mass if I rearrange. So the mass of liquid A is going to be the volume of liquid A multiplied by the density. So my density is 1.21 grams per centimetre cubed, and I want 30 pi centimetres cubed of that liquid. And that will give me 114.0398133 grams. It's really important not to round any of your numbers until the end, because then your answer may not be accurate enough to gain the accuracy mark. So never round anything until your final answer, unless you're told to. And then the mass of liquid B is going to be the density of 1.02 grams per centimetre cubed multiplied by the volume, which is 195 pi centimetres cubed, and that will give us 624.862 7788 grams. So to find the total mass of the liquid in the container, I need to find the mass of liquid C, and that's what I'm going to get when I've mixed this amount of liquid A together with this amount of liquid B. So I'm just going to add up my two masses. So 114.039813 plus 624.8627788, and that will give me 738.902 5921 grams. And the question asks for that to three significant figures, so that will be 739 grams to three significant figures. So our final question, and like the previous question, this one is taken from an exam paper. So there are only red counters, blue counters and green counters in a bag. Number of red counters to number of blue counters to number of green counters is 1 to 3 to 7, and a counter is going to be taken at random from the bag. Question A. Complete the table below to show each of the probabilities that the counter will be red or blue or green. So we've got 1 to 3 to 7. So 1 plus 3 plus 7 will give us 11. So the probability of getting a red counter is 1 out of 11. The probability of getting a blue counter is 3 out of 11. And the probability of getting a green counter is 7 out of 11. Now, Jamie takes at random a counter from the bag and records the colour of the counter. He then puts the counter back in the bag. Jamie does this a number of times. He records a total of 68 blue counters. Work out an estimate for the total number of times Jamie takes a counter from the bag. So he takes 68 blue counters, and the probability of picking a blue counter is 3 over 11. So in order to find out how many counters he's chosen altogether, we're going to do 68 divided by 3 over 11, which is 68 times 11 over 3. And that's going to give me 249.3. So an estimate for the total number of times Jamie takes a counter from the bag will be 249. Thank you for watching.